All right, let's look at a few more examples using the product rule for exponents. Somebody was asking about, what if I just have numbers inside here like this? The cube root of 2 times the cube root of 3. And what is that going to give me?
It's still going to be the cube root of 3 on the outside?
Well, no, the cube root is right here. What's the radicand? What's inside? 2 times 3, so that just gives you 6, right? Now, the reason that we were able to do that is because these guys right here are the same index. Do y'all agree?
Mm-hmm.
And it ends up being right there. Whoops. Ends up being right there on the answer. What, Ivana?
What if they wired?
That's, you know what? That is an excellent question. What if it's not the same index? Okay. So what if I still have the cube root of 2, but I'm multiplying this times the square root of 5? Now we've got problems, right?
No.
It's not, is this the same index? So I can't multiply that according to the product rule. But we also saw something last week where I could rewrite these guys using exponents. So how would I rewrite the cube root of 2? It's 2 to the what power? Right, it's 2 to the 1/3 power times 5 to the what power? To the 1/2 power. Do y'all agree? Now, even with the expression that I have here, I couldn't multiply these guys. Number one, they don't have the same base. Okay? So there's nothing that you could do with those. But remember how the denominator is the index? We've shown that before. The denominator is the index here. Say again? If I can get these guys to have the same denominator, then that means that they would then have the same what? Index, which means they could be combined, right? So how do I get them to have the same denominator? LCD, which is 6. So I can rewrite this guy to be 2 to the what over 6th power?
2.
It's going to be 2 over 6. And 5 is going to go from the 1/2 to something over 6. It's going to be 3 over 6. You're just getting a common denominator. And so what was the missing factor to go from 2 to 6? You were missing a 3. So that's why we went 1 times 3 is 3. Do y'all agree? When I look at this, they had the same denominator, which means they have the same, guess what?
Index.
They have the same index. I'm going to put them in one large radical. What does the radicand look like here?
2 times 5.
It's not 2 times 5. Even though the 6 is for the 6th root,
2 to the square.
you've got 2 squared, and you've got 5 what?
5 there.
You got 5 to the 3rd power. Right? Now, what's 2 squared?
4.
That's just 4. 5 to the 3rd is 125.
Yes.
So then what's my radicand? What do I have here?
We don't have to multiply that out.
4 times, if something's $1.25 and you buy 4 of them, how much is it? It's $5. So the answer here is 500. So that's how you would tackle a problem when they don't have the same index. You can force them to have the same index, but you've got to start by looking at them in their with rational exponents.